Hello everyone, welcome back to 360 on History. As always, please check out our website 360onhistory.com. Join us on all the social media and do check out our YouTube channel 360 on History for videos on science and history topics. You must all have seen an X-ray based fiber diffraction image that was taken by Rosalind Franklin and her graduate student Raymond Gosling in May 1952 at King's College, London. This image was tagged Photo 51 because it was the 51st diffraction photograph that Franklin had taken. And this photo was critical evidence in identifying the structure of DNA. It is basically an image of the double helix structure of the DNA. So, today we talk about Rosalind Elsie Franklin, who was a British chemist and whose work was central to understanding the molecular structure of DNA and RNA, as well as viruses, coal, and graphite. Rosalind was born on July 25, 1920, into an affluent and influential British Jewish family, and she went on to graduate with a degree in natural sciences from Cambridge in 1941. During her final year, she met a French refugee, Adrienne Weil, a former student of Marie Curie, who had a huge influence on her life and career, and who also helped her to improve her French. Franklin then joined the physical chemistry lab of the University of Cambridge to work for a PhD under Ronald George Ryford Norrish, who later won the Nobel Prize in Chemistry. However, disappointed with Norrish's work ethic and lack of enthusiasm, she resigned and took up a research position under the British Coal Utilisation Research Association in 1942. Her research on coal there helped to earn her PhD from Cambridge in 1945. Franklin then moved to Paris for her postdoctoral research, and there she became not only an accomplished but a famous X-ray crystallographer. Franklin subsequently joined King's College London as a research associate in 1951, where biophysicists, including Director John Randall and his deputy Maurice Wilkins, were funded by the Medical Research Council. They were using X-ray diffraction to study the structure of the molecule. Rosalind, meanwhile, had been using the same technique to investigate the structure of coal at the Central State Lab of Chemical Services in Paris. It was at this time that she discovered key properties of DNA that helped to eventually define its structure. While she was originally appointed to work on X-ray diffraction of proteins and lipids in solution, the director John Randall redirected her to work on DNA fibers. This was an emerging and popular field at this time. Randall made this reassignment even before Franklin started working at King's because of the pioneering work by DNA researcher Maurice Wilkins. Randall reassigned Raymond Gosling, the graduate student who had been working with Wilkins, to be Rosalind's assistant. Randall, however, had done this without informing either Wilkins or Gosling. In fact, he made the reassignments when Wilkins was away on holiday. Wilkins and Gosling had obtained a good quality diffraction picture of a highly purified DNA sample prepared and widely shared by Swiss chemist Rudolf Seiner. When Wilkins returned from holiday, he handed over the Seiner DNA to Franklin. This was the background behind the famous friction that developed between Rosalind Franklin and Maurice Wilkins. Franklin continued her work, and together with Gosling, she applied her expertise in X-ray diffraction techniques to the structure of DNA. She refined, adjusted, and focused a new fine focus X-ray tube and microcamera that had been ordered by Wilkins. Her physical chemistry background enabled her to apply a critical innovation to the camera so that the humidity inside its chamber could be controlled. Wilkins asked her about this, and her answer offended him because he felt that she had an air of cool superiority. Their personality clash had begun. With the innovative humidity controlling camera, Franklin was soon able to produce X ray images of better quality than those of Wilkins. She discovered that the DNA sample could exist in two forms. At a relative humidity higher than 75%, the DNA fiber became long and thin. This was known as B form. When it was drier, it became short and fat. This she called A form. At this time, Rosalind considered both A and B form as helical. She presented this data at a lecture in November 1951 in King's College, London. Also in November 1951, James Watson and Francis Crick at the Cavendish Lab in Cambridge University had started to build a molecular model of one sample of DNA using data like that available to both teams at King's. By this time, the conflict between Franklin and Wilkins was developing even further, and so each of them were assigned one form of the DNA sample that she had identified. Franklin worked on the A form and Wilkins on B form. The A or crystalline form, when bombarded with X-rays, produced detailed diffraction patterns, which meant more data and more accurate but more difficult analysis. The B form, on the other hand, produced blurrier pictures but was easier to analyze. Franklin and Gosling continued to work on the X-ray pictures that they had produced in May 1952. Gosling took photo 51, the famous photo of the DNA double helix structure. Although by the end of 1951, it was generally accepted that DNA was a helix, it was photo 51 that confirmed its double helix structure. The X-ray diffraction pictures, including the landmark photo 51 taken by Gosling, have been called by John Desmond Burnell as amongst the most beautiful X-ray photographs of any substance ever taken. Due to disagreements with her director John Rendell and her ongoing conflict with Maurice Wilkins, Franklin finally moved to Birkbeck College in 1953. But she had to leave behind all her DNA work at King's College. Wilkins was given copies of Franklin's diffraction photographs by Gosling as well as all her notes. By this time, Watson and Crick had finished building their model on 7th March 1953, a day before they received a letter from Wilkins stating that Franklin was finally leaving. Now they could collaborate with Wilkins and corroborate their model with the data from the X-ray photographs. Although Franklin had earlier considered the second sample, the B form that was given to Wilkins to work upon, was not a helix, she had later conceded that it was. Examination of the original draft of one of her manuscripts dated 17th March 1953 clearly showed that Franklin had already resolved the correct structure. While her conclusion on the helical nature was evident, she had been unable to understand the complete organization of the DNA strands. The possibility of two strands running in opposite directions probably did not occur to her. Franklin was very methodical and wanted far greater evidence before she would announce anything or publish a model. However, Francis and Crick had by now completed their model, and this news went around like wildfire. Franklin asked permission to see their model, and her cautious nature meant that she retained her skepticism for premature model building even after seeing the Watson-Crick model, and remained unimpressed. She is reported to have commented, "It's very pretty, but how are they going to prove it?" Crick and Watson published their model in Nature on 25th April 1953 in an article describing the double helical structure of DNA with only a footnote saying, having been stimulated by a general knowledge of Franklin and Wilkins' unpublished contribution. These unpublished contributions were all the notes and manuscripts available at King's College, including Rosalind's work that she left behind. So, although her work on coal and viruses were appreciated in her lifetime, Franklin's contribution to the discovery of the structure of DNA were largely unrecognized. Not only was she dealing with sexism rampant during her time in general, she also most certainly must have had to deal with institutionalized sexism within the scientific community. The story that has come down to us from Watson's The Double Helix, where he says that he was presented with photo 51 by Wilkins when Watson visited King's College in early 1953. He had apparently got into a confrontation with Franklin, was then rescued by Wilkins, who then showed him the photo. According to this narrative, Franklin had put aside photo 51 to concentrate on the A form of DNA. So, according to Watson, basically she had just ignored it. Watson said in the double helix that this image showed him that the DNA is a helix. This muted acknowledgement of her work was buried under descriptions of Watson's often quite negative regard towards Franklin during the period of their work on DNA. The discovery of the double helix got Francis Crick, James Watson, and Maurice Wilkins the Nobel Prize in Physiology or Medicine in 1962. When Franklin died in 1958, the DNA structure was not considered to be fully proven. It took them all another 7 years to collect enough data to prove and refine the proposed DNA structure. Franklin and Wilkins' work, including Photo 51, helped to confirm it. Franklin's work contributed immensely to the discovery of the double helix, among other things, differentiating the A and B forms, as well as how DNA could specify proteins. She just did not come to the final conclusions, and Watson and Crick beat her to that answer. According to Watson, Franklin could ideally have been awarded a Nobel Prize in Chemistry together with Wilkins. But she had died, and at that time it was not possible because the rule was that a Nobel Prize could not be awarded posthumously unless the nomination had been made for a then alive candidate before the 1st of February of the award year. There is no doubt that Franklin's experimental data were used by Crick and Watson to confirm and build their model of DNA in 1953. Franklin was not acknowledged, and perhaps that was due to the fact that it would have been very difficult to cite the King College's unpublished work from the report they had seen. Any acknowledgement they gave her was always muted and always in conjunction with Wilkins. She should have been acknowledged, and her King's College data should have been obtained with her permission, which it was not. They did try to set the record straight by admitting in a paper published in 1954 that without Franklin's data, quote, the formulation of a structure would have been most unlikely, if not impossible, unquote. The bottom line is that they all worked on and contributed to the understanding of the structure of the DNA. Rosalind Franklin just did not get all the credit she deserved. At Birkbeck College, working under John Desmond Bernal, Franklin led pioneering work on the molecular structures of viruses. On the day before she was to unveil the structure of tobacco mosaic virus or TMV at an international fair in Brussels, Franklin died of ovarian cancer at the age of 37 in 1958. Her team member, Aaron Klug, continued her research, winning the Nobel Prize in Chemistry in 1982. Franklin also continued to explore another major nucleic acid, the RNA, which is a molecule equally central to life as DNA. She again used X-ray crystallography to study the structure of the tobacco mosaic virus, which is an RNA virus, and she also started the work to study the polio virus. Aaron Klug, Franklin's colleague and principal beneficiary in her will, was the sole winner of the Nobel Prize in Chemistry in 1982 for his development of crystallographic electron microscopy and his structural elucidation of biologically important nucleic acid protein complexes. This work was exactly what Rosalind Franklin had started and which she introduced to Klug. It is possible that were she alive, Franklin would have shared that Nobel Prize. Thank you for joining me once again for 360 on History, and I'll see you again in the next episode.